Now, in this lesson, we're looking at probability trees. Let's consider this scenario. A coin is thrown 3 times. First throw, a second throw, and then a third throw. Well, on the first throw, it could get a head or a tail. Now, if we got a head first time round, on the second throw, we could get a head or a tail. If, on the other hand, we got a tail first up, on our second throw, we could still also get a head or a tail. Now, no matter where we're from, our next throw can always be a head or a tail. Right. Now, so far, that is a tree diagram, okay? You've seen them before. You've seen tree diagrams before. Probability trees are a little bit different in the fact that we're going to assign probabilities or percentages or decimals to each of the branches. So, heads, 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 okay, 3 heads. Head, head, tail, okay. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. The tail, tail, head, and finally the tail, tail, tail. That gives us our list of results in the tree diagram. Right, now they are, at this stage, all equally likely. However, if we start assigning probability branches, then that changes things. Let's look at an example. A coin is biased, alright, so that it has a 60% chance of landing on heads. If it is thrown 3 times, find the probability of getting A, 3 heads, B, 2 heads and a tail, or C, at least 1 head. Right. So we can see this is a little bit different, okay? Normally when we toss a coin, we expect a 50-50 chance. But we're saying this is biased, 60% chance of landing on heads. So where we see all those heads, okay, those branches leading to the heads, we're going to write 60% on those branches, okay? Well, that's a decimal in any case, 0.6. So, what about getting a tail then? Well, let's look at all these branches. If we have 60% chance of landing on heads, only leaves 40% left for the tails. So as a decimal, that's 0.4. So let's put 0.4 on each of those branches. Okay, now, we've got to find the probability of getting 3 heads. So, in other words, probability of a head, head, and head. So that's where it occurs. Okay, let's see what's happening leading up to that result. Along those branches, 0.6, 0.6, and 0.6 again. We multiply the branches together. So we're going to get that, and that works out to be 0.216. Now part B, probability of getting 2 heads and a tail. Well, probability of 2 heads and a tail in that order. Or we could get a head, then a tail, then a head. Okay, that's 2 heads and a tail. Or the other way, getting the tail first and then 2 heads. So we need to make sure that we cover all the situations possible. Now the first one, 2 heads and a tail, that's where it occurs. Now how do we get there? Okay, looking at those branches, we need to multiply those values. We get 0.6 squared. Okay, there's 2 of them. Then we multiply by the 0.4. Now the word or in probability tells us to add. Now let's consider this scenario, head, tail, head. Well, how do we get there? Let's look at that. Those 3 branches lead us on the way. The 0.6 occurs twice again with the 0.4, so we can multiply again 0.6 squared times the 0.4. Now the word or again, let's add. Then the other way we can get is 2 heads and a tail. Okay, the 2 heads at the end though. That's where it occurs. So we have the 3 branches. Again, there's 2 lots of those 0.6s. So when we multiply, we get 0.6 squared times the 0.4. Excellent. Now, all we need to do is calculate that. You may have spotted a quicker way to do that. Have a look. Notice that each of the brackets are the same. They're all 0.6 squared times 0.4. So you could work out one of the brackets and simply multiply by 3. Okay, 3 lots of it. In any case, we get 0.432 as our answer. Part C now, what's the probability of getting at least 1 head? Well, let's write that down. Now let's look at our diagram. To get at least one head, that just means one head or more. Well, it happens there, happens there, it happens there, and there, and there, and there, and there. Well, it happens everywhere except for the bottom, right? The three tails, okay? Happens everywhere else. So we can say, rather than try to work out those 7 results there, take us quite a while, let's work out one result and take it away from one. Alright, because we can say it happens all the time, which means in probability 100% of the time, okay, right, equals 1, except when there's 3 tails. So let's subtract the probability of getting 3 tails. So we have the 1 there, let's write that down, and the chance or probability of getting 3 tails, let's have a look. There's our 3 branches. So we subtract the 0.4 cubed, okay, it's multiplying by itself 3 times there, so 0.4 cubed. And when we calculate that, works out to be 0.936, right, which is a fairly high number, given that the highest number in probability is 1. Excellent. Our second example now. In a bag of 10 marbles, 3 are red and 7 are green. 2 marbles are drawn out at random. Now with the aid of a probability tree, we find the probability of A, choosing 2 red marbles, B, choosing 2 marbles that are the same colour, and C, choosing different coloured marbles. So what have we got? We have 3 red and 7 green. Let's draw them in. Now with the aid of a probability tree, so we're going to draw a probability tree. We have 2 marbles being drawn out. So first marble and second marble. Now the first marble could be a red or it could be a green. Now what's the chance of it being red? Certainly not as good as the chance of being green. The chance of it being red is 3 chances out of 10. Okay, 10 marbles altogether. 3 of them are red, so 3 out of 10. What was the chance of pulling out a green one first? Well, there were 7 chances out of the 10. So make sure with a probability tree we assign each branch with a probability. Now let's consider drawing the first one as being red. Now look at our diagram. Let's take a red away. Alright, so our second one could be a red or it still could be a green. The chance of it being red though, have a look at our new diagram. There's only 2 red ones, isn't there? How many marbles altogether? 9. So the chance is 2 out of 9. What about the probability of getting a green one at this stage? Well, much bigger chance, have 7 chances out of the 9, so 7 out of 9. Right, let's put our red marble back. Now what if our first marble in fact was green? So let's take a green one away. Well, our second marble could be a red or could be a green. The chance of it being red, have a look at the diagram. There's 3 marbles out of the 9, so there's 3/9. That's the chance of it being red. What about the green? Well, how many greens are left? There were 6 out of the 9, so the chance is 6 out of 9. Right, now that's really the hard part done, okay? Once you've got your probability tree, the rest is easy. Let's put our marble back, okay, otherwise we might lose it. Righto, 2 reds, alright, first one, next one, red green, next one, green red, finally green green. Now I think we can start answering some questions. What's the probability of choosing 2 red marbles? So probability of RR, okay, 2 reds, there it is. So to get there, 3/10 and 2/9. We need to multiply those 2 fractions. We end up getting 1/15. Part B, what's the probability of choosing 2 marbles that are the same colour? Well, the probability of them being the same, we could get a red red or we could get a green green. So the probability of getting a red red, we've actually worked that out. It's 1/15. Let's write that down. Or, that means we should add probability of a green green. Well, from our diagram to get to green green, there are our 2 fractions. So we multiply 7/10 by the 6/9, and when we calculate that all together, we get 8/15. Finally, what is the probability of choosing different coloured marbles? Well, the probability of a different equals probability of getting a red then a green, or we could get the other way around, a green then a red. So red and green firstly. There it is on the diagram. So that's 3/10 and 7/9. Let's multiply them. Or, so we add. To get a green red, let's have a look. There it is. So to get there, we need to multiply those two fractions. So 7/10 times 3/9. And calculating that, our final answer there is 7/15.